Hello everyone, and welcome to the One Community Project's weekly webinar series brought to you by ProviderSearch.com. You can join us every Wednesday at 2 p.m. Eastern Time to gain insights from different professionals around the world. My name is Tyler Burke, and I'm the webinar organizer and today's moderator. It is my pleasure to introduce Dr. Bob Zenhausern to today's program. Dr. Z taught neuropsychology, research, and statistics for 35 years at St. John's University. His major research focused on the neuropsychology of learning disabilities, and the talk today is an outgrowth of that research. He retired a full professor in 1998. He was a pioneer in online education starting in 1981 with an emphasis on K through 12 and persons with disabilities. In 1994, he developed the online component of the Enabling Support Foundation, or ESF, and became the CEO when he retired. Currently, ESF is providing web hosting and online professional development in emerging countries, most of which are in sub-Sahara Africa. He has created the Archive of Social Good, a directory of organizations that support human development that can be searched by country, population served, and mission. So Dr. Z, thank you so much for joining us today.
Oh, Tyler, you're welcome. It's been good to be here, and looking forward to a rant in 3 parts. I hope everyone can see that. Okay, I always say to begin with a story, so I'm going to tell you the story of a collie that could read. A student of mine had this beautiful, intelligent collie, and she was showing off how when she held up the word sit, the dog would sit, held up the dog speak, the dog would speak, shake, and the dog would show the paw. And then all of a sudden, at this point, my first reaction was, wonderful, Skinner was right, nice conditioning. Then she held up the words, lie down, which meant lie down in your corner and don't bother anybody, which was not what the dog wanted to do. And the dog turned his head away and covered his eye with his paw. That, to me, shows the dog could read. It knew what the words meant. It knew the implications of it. It knew everything it needed to know about it. The only thing it couldn't do was say it. Okay. Slide wouldn't change there for a moment. Okay, what is reading? What's it got to do with this? Well, reading doesn't mean speaking. Reading means that the print has meaning. It means that when the person or the dog sees the word, it has implications for the rest of the life. It means to understand what the printed word means. It's true for the dog, the deaf, they can't say it, but they know what it means. And the dyslexic, they know what it means, but they can't say it. And we'll talk more about them in the second part. But let's talk about the way we teach reading. We start off with showing the child all the letters of the alphabet, the sounds of that. We repeat that A, B, C, D so often that we'll be singing it in the grave. It is part of everything that we're doing. And when I say teaching backwards, what I'm saying is, as it says there, postpone the alphabet until the student can read the word. How do you teach reading if you don't teach them how to decode the word, to take that word and make it into a sound so you know what it means? Remember how you learned how to speak. Parent held up an object or pointed to something and said the word until you make the connection and you too can say the word. They didn't start letter by letter or sound by sound. It was word by word. And so that, why not teach reading word by word? You might pair the printed word with its sound. You might show a picture of it. You might show an object. All you have to do is to make that comparison. And any child, probably could do it, will learn and develop a rather large vocabulary very, very quickly using this kind of approach. Now, once the person can read the words, knows what they mean, now you teach the letters of the alphabet in their sounds, in the context of what they're doing. They know what the word means. Here's the letters, and they tie in the letters and the sounds. And this would be the place where you would teach phonetic decoding for those cases where it might be useful as a useful tool. But whether or not they learn the phonetic decoding, they can read and get meaning from the printed word. Okay. Now, think about the process we have of letter by letter by letter by letter and sound. If you don't have to start that way, you can start immediately with using words compared or paired with pictures of objects. And the most logical way of doing that is to have parents teach the children to read at the same time as they teach them to speak. It's a combination of reading and speaking, and my guess is that if this goes on the way it's going, and we have the apps that people are using now, children will be texting by 3 years old and coming to school reading and writing. Then comes the problem of what do we do with them. There's a URL on the board, brillkids.com. Scroll down to the bottom of that, and you'll see what they mean by babies reading and how they can read before they can speak. Now, another part, dyslexics can't rhyme. I was doing a lot of work with school psychologists at St. John's, and one thing that kept coming out is that dyslexics have a difficulty rhyming when compared to students who do not. Who can read normally. We ran a test, it was a Ph.D. dissertation, where we paired words. Like, take a look at the words on the first line there, and we asked them, do they rhyme? And as we might expect, the dyslexics were the ones who were significantly worse than the average reader on being able to do this rhyme. They did not know the sound of the word. The next line shows the second task. In this task, we were dealing with do the people know the meaning of the word? So, for example, do they mean the same or opposite? gone away. It's the same, the meaning of it. Oh, and words that are just unrelated, that there's no relationship. The dyslexics on the meaning task knew exactly what the words meant. They did not have any deficit compared to the average reader on that. So that they knew the meaning of the word, but they could not say those words. Sounds like the collie. Now, is that important? It's important because it ties right into the way we teach reading. What we do is we have a word, we convert the word to its sound, and from the sound, you know what it means. 80% of dyslexics can't take that step. That's where they that's precisely what they cannot do. We keep trying to ask them to do what they cannot do. You might consider dyslexia like a tip of the tongue on a chronic level. Think of what it feels like when you know everything about a word but cannot say it. That is what dyslexia is all about. Brain studies have shown that there's a part of the brain responsible for phonetic decoding, and this part, excuse me, stop tickling here, and this part is not active in dyslexics. So precisely in the system where phonetic decoding is contained, left angular gyrus, the dyslexics have a problem with that area. It is a known physiological fact. But somehow it's okay to try and fix a broken system rather than for looking for ways to get around it. They make allowances for the blind, for the deaf, but the reading disabled, the allowances are made is extra practice on what they can't do to begin with. Why is it ignored? Yeah. There are teachers, the true believer, who will say that unless you have phonetic decoding, you're not really reading. They believe it. One of them has actually said that comprehension is a byproduct of reading. Another part of the whole thing is the phonics lobby. What would happen if phonics was no longer needed for people with disabilities? Even more so, what would happen if parents started teaching their children to read to begin with? There would be no such thing as dyslexia. As there is, well, dyslexia would probably be as common as alexia, the inability to speak. And it's probably would be rare, but very serious. Okay, so my point is what we need the students to do when they're learning to read is go for the meaning and let the sound come later. One of the things that I've uh, again, sorry, recently come across. Actually, it comes really out of my lack of visual imagery. Now, this is something, I remember in the second grade, I was in front of there with a rest of the kids, and the teacher said, I want you to image something. And I looked around, and everybody was imaging something. But I didn't see anything. I don't know if other people were faking it, but I really never saw anything. And I really didn't think too much of it until I met a student of mine in graduate school. I was a professor at that point. And when I mentioned that I didn't have visual imagery, her reaction was, how do you think? That was a turning point minute. That's what started me on this whole journey that we're going on today, going off in all different directions. How do you think? And I ultimately said, I think by talking to myself. And to the student, thinking meant seeing all these pictures. And it started a whole movement that was going along with a lot of the stuff going on in terms of left hemisphere versus right hemisphere and the orientation there. Well, we know speaking takes place in the left hemisphere, so it's easy to make connections there. And imagery has been associated with the right hemisphere, so that comes in. But then they found out that letter imagery is part of the left hemisphere. And we have speaking, and we don't have hearing. It's I'm not quite sure where that fits in, but try this. When a song runs through your head, who is doing the singing? Whenever I ask this question, I get about a 50-50 split between those who say, I hear the singer, versus those who say, it is me doing the singing. So think about those. You're hearing something versus you're saying something. You're seeing images of picture imagery. You're seeing letter imagery. Okay. Now, I said I do not have visual imagery. How is your visual imagery? How would you rate your visual imagery compared to, if reality is 10, how good would yours be? Mine would be 0. There are people who go as high as 10, and there are people who go 2s and 3s, and a couple of 0s like me. Not a lot, but a few. What's an interesting thing to check with people, when you image with your eyes open or closed? Again, that's about a 50-50 split. Some people image naturally with their eyes open, some with their eyes closed. And the thing that I found most interesting is that about half of those who image better with their eyes open image poorly with their eyes closed. In other words, closing their eyes for these people decreases visual imagery. And how often do we say, now close your eyes and imagine blah, blah, blah. Okay. So, Oh, take a look at the letters that you image. Okay? What kind of letters are they? In other words, image a word and tell me what kind of letters you see. Are they white on black, black on white, colored, script? So many different ways they could be. But let's see how this all ties into the way you're thinking and how this goes through. I want you to remember these 5 words: dog, cat, tree, table, and chair. Can you repeat them? Most people can. But ask, how did you remember those words? You're going to find people who say that they saw pictures of them. There are those who say that they saw the letters. There are those who say they repeated them. I'm one of those. And there are those who say they heard them. Okay. These are different ways that people learn to think and remember. And they're very important when you're dealing with individual differences and how you use teaching techniques for this. For example, there are individuals, and there may be as many as 50% of any class, where if they have to repeat something when they're learning it, they learn less well. In other words, a verbal repetition approach hurts certain kinds of individuals. It makes their performance worse than it was before that. Now, an alternative to that, especially as it comes in to spelling. We use spelling as a good example. Typical way to teach spelling is to cat, C-A-T, cat, and writing it at the same time or not. But that act of verbal repetition interferes with learning for some kids, and most of all with dyslexics, since most of the dyslexics fall into this particular category. So with spelling, again, with spelling, show the student the word and ask the student to image the letters of that word. Don't say anything, but form the image of that word. And the letters are there. Practice that. Then when it comes time to spell the word, bring back the image and copying it down. Another kind of thing that this is related to is can you hear the printed word? Not just by saying it, because when you say it, you hear it, but you hear it just by itself, so that the word comes up and you know what it means. There are people who say when they're reading a novel, it's like somebody telling them a story. They hear the words. It's like when a song runs through your head, you're hearing the singer. So, can you hear the printed word? And if a dyslexic can hear the printed word, is there a way to take advantage of that to increase their reading. Going through the same kind of idea as getting rid of phonetic decoding, speed reading literally means reading without phonetic decoding. You're getting the meaning of the word directly rather than through its sound. Japan has an interesting education or reading system. Children start out with a phonetic form of the Japanese language until about the 3rd grade. Then, when they're ready for serious reading, they move to the pictographic, and it's almost as if phonics was training wheels for reading. I think we place too much emphasis on it here in the U.S., but I guess that's pretty clear. I have a questionnaire that I use for the excuse me again. This idea of consciousness. One of the other things that I was doing with that, and this was interesting now that I'm thinking about the questionnaire. If you ask people, do you read music? And if you do read music, can you hear the notes? You will find that not everyone can hear those notes who can read music. So that it's about a 50-50 split between those musicians who can read the notes and those who can hear the notes that they read, and those who cannot. It's about a 50-50 split. If you go up to that URL there, you will see a set of forms that you have, and one of them is the consciousness survey. It asks questions like this that we've been talking about here, and trying to keep track of the proportion of people who do and don't, and we're doing it across cultures, because we're also working in Africa, where we're providing web hosting and a certain amount of professional development for these people. And a few of them have started using the reading method, and may be one of the first places that actually will be using it in any substantial form.
Dr. Zenhausern,
yes.
We are running pretty low on time, so I hate to cut you off. As interesting as this is, I do want to make sure and at least get in one of the questions that we have.
Okay.
Is this something that can be done with math as well? Can math be taught backwards?
Not so much backwards, but with a slightly different slant. Two steps. Step one is substitute estimation for arithmetic. Most of the time, it's good enough to have a solid, approximate answer. And if you do need an absolute precise answer, you're not going to be trusting the human brain as it is anyway. You will teach the people how to use a calculator under those circumstances. But for their day-to-day work, we're looking for estimation. I don't know what good estimation means. What it means within 10% of the real answer. Probably there'll be a variation of that, just like there's a variation in arithmetic. But until we start measuring the percentage of the trusting accuracy more than precision, we won't know what a quote good score is. I think that will take a lot of the problems out of teaching mathematical concepts, that you don't have to spend all that time doing crazy arithmetic. I think this is practice, or probably should be done in parallel with teaching math on a spreadsheet. On a spreadsheet, you don't have to worry about whether the arithmetic is right or not. You can put out your formulas, you can write them there, understand where things go. Given a word problem, you have to then take the pieces, put them in the right place, and put the right formula in there. Goal-seek will solve any one-level algebraic equation that you could ever want to imagine. It's all in there, so that the concentration is on creating the equation, not doing the arithmetic. I think a side benefit of that would be to take a look at science, the STEM, science, technology, engineering, and math. I think that arithmetic has done more to hold back science than any other problem. I think that if we get first graders on a spreadsheet, you can start giving them research problems from the get-go, because they have to understand and concentrate on that. Again, this I think will be part of the apps that the babies will be getting, so that not only do I expect them to be coming to school reading and writing, but to be proficient on a spreadsheet and probably on the internet too, or at least some form of it.
Well, Dr. Zenhausern,
Okay.
thank you so much for being on today's program.